everyone. I guess you're all doing well today. Are you refreshed for the lab today?
Yes.
Okay, so we are continuing with our nanoparticles studies. Last week we prepared nanoparticles, and then today we are looking at their characterization using the UV. So this is not the first time you've used the UV, right? You already know the principles behind the UV. The Lambert's law, A is equal to epsilon. Continue.
The length of the part.
But that's the concentration.
Awesome. And the path line, right?
Yeah.
Awesome. So today we are coming to use this UV. I've already set it up, and these are samples. Can you see it from here? Are samples. You know that nanoparticles do have optical properties, right? Which is related to their size, their concentration, their refractive index on the surface of the nanoparticle. So all of these contribute to this optical properties. We are going to use the UV to know the size approximately, and then know the concentration of our synthesized nanoparticles. Okay, so first, we know that before we can use our UV, we need to have a blank. So the blank is the solution that you have your nanoparticles in, and that is what? Water. So our blank is going to be water. Yeah. So let's set it up. You already have our lamps on. So you have to use the Kim's wipe to clean it up. You don't have to have your fingerprints on it. Very simple. And then you press blank. Simple, right? Okay, so we want to see a very straight line. That is what we're expecting because it's just water. When this is done, it subtracts the solvent from your nanoparticles. Cool, this is not good, so we have to try again. We want to have water subtracted from our nanoparticles, so to give only the concentration of the nanoparticles. So this could be okay for a blank. So now let's move on to analyzing our samples. And you know that we took 3 different concentrations of our nanoparticles, and those contribute to their sizes. So with the UV patterns, you are going to know that this is a bigger particle, this is a smaller particle, or this is a medium-sized particle. So let's take a look at this. Since we already know that particles or nanoparticles are concentrated, we have to dilute it. So we take with the least concentration. So we take about 100 microliter. And then we take about 650 of water. Don't forget to wipe. You don't need your fingerprints. You need a clear light to pass through our sample. So now you have to press sample, and then this runs. So let's see the magic the UV gives us. Boom, you see that there's a hump here. This shows the gold nanoparticles with the SPR of this. So this shows that it has a broad SPR, and it tells us that the particle size is big. So as we move on to the other concentrations, you know the difference. Looking at the SPR, you are going to know that its particle is bigger or smaller or medium size. So let's try the next one. So after first run, you have to just wash this off with water. So this is what I do. So you want to look at me, do the same. As you get to your lab bench, you do the same thing. And if you have any questions, you ask me. I'm always around to help. So make sure you change your pipette tip. And let's try the second one. This is a 250 microliter sample. take it here. Dilute. Don't forget to wipe. It will keep resounding your ears that not. Do not forget to wipe. So from the UV, let's see the magic again. Boom, you see the difference, right? So knowing this, you know that this particle size is smaller than the previous one we did. This is giving us a very clear understanding of the particle sizes. So it makes characterization using UV for nanoparticles very good, and it's very efficient. Let's try the last one to see. If you have any other question in your mind, just let me know. This is kind of simple now, but it needs practice. Change the tip for the next sample. Do the same again. Dilute.
I have a question.
Okay.
So, UV, does it only tell us the size of the nanoparticle? Can it also tell us like the amount of the particles you have in you?
Yeah, so with the UV, it can also tell you the amount, and it can also tell you the polydispersity of your nanoparticles. Looking at this, it will tell, this has a broader one, tells you that it has, it's more polydispersed, right? Awesome. That's a great question. Good job.
Thank you.
So let's see the next one. Boom, you see the difference. So looking at this, we can successfully say that we have notified that particles are really different. So looking at the concentrations and the SPR bands, we have different sizes of nanoparticles. So you can look at this and do same on your bench, right? Do you have any other question?
I have one question.
Okay.
Are the other peaks there in the beginning important, or is it just that little peak that's significant for
This
us?
is the significant peak that we need, yeah. So that's where the gold nanoparticle absorb.
I see.
It absorbs around 520 and 5 up to 600. It depends on the size of gold nanoparticles you have in your solution.
Okay, that makes sense.
Awesome. Any other question? Okay, so you can all now move to your bench, and then you start this lab safely. Don't forget to wipe the cuvette. Don't forget to dilute. Don't forget to change the tips of your pipettes, and then you're all done. If you have any other question, just let me know. Awesome.